Welcome to the Military Breakdown Podcast. You're joining us for a really fascinating look today at something pretty unique in military aviation. It's called the Frankenjet.
That's right. It's quite the nickname, isn't it?
It really is. We're diving deep into how they actually built an operational F-35A stealth fighter, basically using parts from two other jets that were already damaged.
Yeah, and this isn't just, patching something up. This was a whole different level, a first-of-its-kind thing, really.
Exactly. It tells us a lot about how valuable these F-35s are and maybe points towards new ways of keeping them flying.
Definitely. It opens up questions about repair, sustainment, all that good stuff.
So today, we want to, break it down. How did this Frankenjet idea even start? How'd they build it? What was the timeline, the cost?
And crucially, why does it matter? What's the significance for the Air Force? And how does it fit into, the bigger picture of military aircraft maintenance?
Okay, so let's start right at the beginning. Where did the concept come from?
Well, the idea really started to take shape back in late 2022. It wasn't just one group. It was a joint effort. You had the Air Force's F-35 Joint Program Office involved, working very closely with the maintenance folks, the 388th Fighter Wing Maintenance Group at Hill Air Force Base, and of course, Lockheed Martin, the manufacturer.
Okay, Lockheed would have to be involved.
Absolutely. And the core question they were asking was, basically, look, we have these two F-35s, both pretty badly damaged, but not completely destroyed. Can we, take the good bits from each and make one good plane?
So salvaging the best parts, essentially. A high-tech salvage job.
Pretty much, yeah. The main idea was find the undamaged nose section from one jet that couldn't fly anymore and attach it to the rear section of another grounded F-35, provided that rear section was largely okay.
Okay, so they had specific aircraft in mind.
They did. They identified two specific airframes. The first was known as AF-27. Its serial number was 105015.
AF-27, got it.
And the second one was AF-211, serial number 175269. Each one had, a pretty unfortunate backstory.
Right. I remember hearing about AF-27. That was the one with the fire, wasn't it?
Exactly. Back in 2014, down at Eglin Air Force Base, it suffered a really catastrophic engine fire.
Ouch.
Yeah, it basically wiped out the rear two-thirds of the plane. Pilot got out okay, thankfully.
That's the main thing.
It is. But what's kind of interesting is that even after that, parts of AF-27 weren't just scrapped. They actually refurbished some sections to use as a training aid.
Oh, really?
Yeah, an air battle damage and repair trainer, ABDR, up at Hill Air Force Base. So it was still providing value, even grounded.
That's fascinating. Even broken, it helped train others. Okay, so what happened to the other one, AF-211?
AF-211's incident was more recent, June 2020. It was landing at Hilladale after just a routine training flight, and the nose landing gear malfunctioned.
Oh, the nose gear. Okay.
Yeah. Pilot walked away, again, thankfully. The initial reports focused on the gear, but when they looked closer, the damage, particularly to the front section, was significant enough to take it out of service. But its rear section was largely intact.
So one plane with a good nose, bad tail, another with a bad nose, good tail.
You've got it. It sounds almost simple when you put it like that, doesn't it?
Yeah, like Lego bricks.
Yeah.
But I imagine fusing two stealth fighters together is slightly more complicated.
Just a bit. This was the real challenge. You're talking about demating, taking apart, and then remating, putting together huge sections of two different F-35s, something never, ever done before with this airframe.
And the tolerances on a stealth jet must be incredibly tight.
Ridiculously tight. Think about it. Every tiny gap, every panel alignment, it all affects the radar signature, the stealthiness. You can't just, bolt it together and hope for the best. It had to be perfect.
So how did they actually tackle the construction? What did that involve?
Well, it meant they needed brand new tools. Completely new, specialized tooling, fixtures, equipment, all designed and built just for this one specific, very complex job.
Wow. Where did they do this work?
That happened at the Ogden Air Logistics Complex, the OALC, which is also at Hill Air Force Base in Utah. That became kind of the main workshop for the Frankenjet.
And I bet the engineers were sweating the details.
Oh, absolutely. The Lockheed Martin engineers really stressed how complex this was. Because of those tolerances we mentioned, even the slightest misalignment could mess up the stealth, the aerodynamics, everything.
So precision was absolutely key.
Critical, non-negotiable. And here's something really interesting they did. They actually designed this new specialized tooling to be potentially transportable.
Transportable? How?
They designed it so it could, in theory, be broken down and packed into standard shipping containers.
Okay, now that sounds significant. Why?
Well, think about the implications. If you can ship the tools, maybe you could do similar major repairs somewhere else, like a forward operating base, not just back at a main depot.
Reducing the need to ship a damaged plane all the way back home.
Exactly. Could massively cut down repair times in a conflict scenario, for instance. Big potential implications there.
Definitely something to keep an eye on. Okay, so bringing it back to the Frankenjet itself, what was the main purpose here? Just getting one more plane flying, or was there more to it?
Well, getting another F-35 back into the fleet was definitely the primary goal, yes.
Yeah.
Taking two unusable assets and turning them into one valuable operational combat aircraft. It's about maximizing the investment.
Makes sense. Sort of like recycling, but on a multi-million-dollar scale.
Kind of, yeah. But it was also a really important test case, a first-of-its-kind experiment, like we said. They wanted to prove out these new repair techniques for really badly damaged F-35s.
Pushing the envelope on what's fixable.
Precisely. The bigger picture goal is to get better at repairing these advanced jets, find ways to repurpose damaged ones, cut down on waste, and hopefully reduce the massive costs involved in maintaining these fleets.
And I assume they documented everything. Every step, every problem.
Oh, meticulously. Every single detail of taking them apart, putting them together, the challenges they hit, the solutions they came up with. All of it.
Why is that documentation so important?
Because the idea is to use all that data to create standardized repair procedures for the F-35, things they can integrate into regular maintenance operations down the line. So the next time something like this happens, it's not starting from scratch. It's more efficient, more predictable.
Learning from this one-off to make future repairs easier. That's smart.
Yeah, it shows how valuable these planes are considered, that they'd go to these lengths. It makes combining damaged jets seem like a relevant strategy now.
Okay, let's talk brass tacks. The timeline and the cost.
Yeah.
How long did this whole process take?
Right. So from when they first had the idea in late 2022 to when the Frankenjet was actually declared fully ready for operations, it took about 2 years and 5 months.
2.5 years, basically. That finished up in March 2025.
Correct. March 2025.
Huh.
That time frame alone tells you this wasn't a quick fix.
No kidding.
Yeah.
When did it actually fly?
The first flight of the combined aircraft was in January 2025.
Okay.
But that was just a ferry flight, basically. It flew from Hill Air Force Base, where it was assembled, down to Lockheed Martin's place in Fort Worth, Texas.
Back to the manufacturer for final checks.
Exactly. For all the final maintenance, systems checks, calibrations, making sure everything was absolutely spot on from the people who built it originally.
Makes sense. And then it came back.
Yep, returned to Hill in late March 2025. And that's when it got the green light fully operational, assigned to the 4th Fighter Generation Squadron, part of the 388th Fighter Wing, ready to go.
So it's a real contributing asset now, not just an experiment. That's impressive. What about the money? How much did this cost?
Okay, the total price tag for the project came in at $11.7 million.
$11.7 million. Okay. How does that compare to, say, what they expected?
Well, here's the kicker. That was actually $2.8 billion less than they originally budgeted for it.
Wow, under budget on something this complex and new. That's pretty unusual.
It really is. And the saving story gets even better.
Oh, yeah.
The Air Force crunched the numbers. They estimate that doing this rebuild saved the Department of Defense around $63 million overall.
$63 million. How do they figure that?
By comparing the $11.7 million rebuild cost to the price of buying a completely new F-35A off the production line, which is roughly $80 million these days.
Okay, that's a huge difference. Less than $12 million spent to get an $80 million capability back online. That definitely makes the case economically.
It certainly puts the cost in perspective, doesn't it?
It does. So, thinking bigger picture now, we've got the cost savings, we've got the extra plane. What's the broader significance here? What does this achievement really mean?
Well, first off, it just demonstrates a whole new level of repair capability for these very advanced, very complex stealth fighters. It proves that even really severe damage doesn't automatically mean an aircraft is a total write-off anymore.
Right. It changes the calculation for what's salvageable.
Exactly. It boosts the potential resilience of the fleet, and as we just talked about, it highlights the potential for some serious cost savings by getting creative with damaged airframes. That could influence how they approach repairs versus replacement for other expensive platforms, too, not just F-35.
And you mentioned this built on previous experience, right? It wasn't completely out of the blue.
Oh, definitely not. They absolutely leveraged lessons learned from years of maintaining the F-35 fleet already, but also from repairing damaged F-22 Raptors.
Ah, the Raptor. Another complex stealth bird.
Right, and fixing a damaged F-22 can take a long time and cost a fortune. There was one repair that reportedly took years and cost something like $35 million.
Okay, so compared to that, the Frankenjet timeline and cost look pretty good.
They do. It suggests they're getting better, more efficient at handling these advanced materials and systems. There's a growing expertise there.
And that transportable tooling idea we discussed earlier.
Yeah, that's got potentially huge significance for things like agile combat employment, ACE, and distributed operations.
How so?
Being able to do complex structural repairs closer to where the planes are actually operating from. That increases flexibility, makes deployments more resilient. You're less reliant on massive fixed depots far away.
Reduces the logistical tail, potentially.
Could do, yeah. And this whole project really underscores the military's focus on tackling the sustainment challenges of these advanced jets. Things like getting spare parts, keeping maintenance manageable. These are big ongoing issues. The Frankenjet offers one creative solution pathway.
So it's part of a bigger effort to keep these high-tech fleets affordable and maintainable in the long run.
I think that's fair to say, yes.
Now, you touched on this earlier. This idea of combining parts from different vehicles isn't totally unprecedented in the military, is it?
No, not at all. There are some interesting historical parallels. The Navy, for instance, has done similar things, sometimes called Frankenboats.
Frankenboats? Like what?
Probably the most famous example is the submarine USS San Francisco. It hit an underwater mountain back in 2005, badly damaging its bow. Yeah. To fix it, they actually took the entire bow section from another submarine, the decommissioned USS Honolulu, and grafted it onto the San Francisco.
Wow. That's major surgery in a submarine.
Absolutely. Shows incredible engineering. And the Air Force has done it, too.
With planes?
Yep. They created what they called Franken Tiger jets. These were used for adversary training, playing the bad guys.
Okay.
They basically took usable parts from different retired F-5 Tiger aircraft and combined them to create functional training jets. It was a cost-effective way to keep those adversary squadrons equipped.
Resourceful. Making the most of what you have.
Exactly. And it's not just the U.S. military. Other countries have done similar things when needed.
Quite cool.
The Finnish Air Force, for example, they created a unique two-seat F-18 they called the Franken Hornet.
How did they make that one?
They took the front section of a single-seat F-18C that had been badly damaged, and they merged it with the rear section of a two-seat CF-18B they got from Canada. Again, necessity driving innovation.
It really seems like common sense when you have such expensive equipment, finding ways to reuse parts.
It does make practical and economic sense, but, while Frankenjet was a success, it's worth remembering some caveats.
Such as?
Well, how easy would it really be to do this kind of super complex repair out in the field at a forward base? Resources, time. It might be much harder than doing it at a fully equipped depot like Ogden.
Good point. Scalability might be an issue.
Scalability and also the overall cost-effectiveness depending on the specific damage. Is this always the best approach? Or only in certain situations? Those are questions they'll need to figure out.
So it's a great proof of concept, but maybe not a universal solution just yet.
Exactly. It shows what's possible, but figuring out where and when it's most practical is the next step.
Understood. Well, regardless, the story of the Frankenjet is just really impressive. It speaks volumes about the skill and, frankly, the determination of the Air Force maintenance crews and their partners at Lockheed.
It really does. A testament to ingenuity in solving very tough problems.
It gives us this fascinating window into that whole world of high-tech military maintenance and the constant effort to keep these vital aircraft ready to go.
And it definitely makes you wonder, doesn't it? What other feats of engineering that seem impossible today might they pull off tomorrow?
Absolutely.
Yeah.
A very cool story. Well, that about wraps up our breakdown of the F-35 Frankenjet. What are your thoughts on this? Let us know in the comments. And if you found this interesting, please share it with anyone you think might appreciate a deep dive into military technology. Don't forget to subscribe to the Military Breakdown podcast for more analyses like this one. And be sure to check out our other episodes for more explorations into the world of defense. Thanks for listening.